Do I have to? Oh, maybe. There's the audio.
Don't use it in the chat.
Figured it out. All right. Can I switch that? Turning that down.
And if I flipped it, didn't everything, I think I would have done it.
Okay. That should be good. And then that should be good. Okay. Yay, we have audio. Now, how did I get that there? That way that's small and that's out of the way. Will it still let me talk? Yes, it will. Okay. Perfect. Yay, figured it out. Okay. Thank you for bearing with me during those. I've never used this before, so I'm becoming a professional now. Yay. Start streaming on Twitch. No. All right. All right, so I just finished up with exponent rules. Now we're continuing with writing radical notation. So when we have these fractional exponents, they represent radicals, where if you're talking over me, it's really distracting. So you are free to engage and ask questions, but side conversations need to not happen. Understood?
Yes.
Thank you. All right. So the numerator represents the exponent, while the denominator represents the index or the root that we are taking for that expression. So when I have 1/3, the 1 represents me raising it to the first power, but the 3 represents me taking the third root. So I can rewrite this expression as the third root of -216 x to the 9th. Okay, and this whole thing is just being raised to the first power. I don't need to write that exponent of 1, so we can just rewrite it as the third root of -216. And then from here, we can just simplify the expression as much as possible. We want to look to see, well, can we take the third root of -216? If memory serves me correctly, that should be 6, and it is. So we have the third root of -216 is going to be a -6. And then the third root of x to the 9th, we divide the exponent by the index, which gives us x to the 3rd. Okay. Why did my screen stop sharing? Oh, because I must have hit the stop sharing button on accident.
Do you want me to look back and see if you're
I've got it up here just in case. That's how it went away. All right. Yeah, there's this thing that says stop sharing at the bottom, and I accidentally clicked it, and that was bad. Should be good now. Still have audio. Oh, I have to put it on stage. Ah, that's annoying. I really do need 2 screens for this. There we go. Much better. Okay, so 9 divided by 3, that gives us the exponent of 3. When we have the 4 and the 5, so again, that 4 becomes our exponent and the 5th becomes our root. So we can write this as the 5th root of 243 to the 4th power. And then we can go and take the 5th root of 243, which I think is probably 3. I'm just double checking. 243. 3. Am correct. So the fifth root of 243 is 3 to the fourth power, and then 3 to the fourth power equals 81. So we're able to simplify that expression. Yes, ma'am.
Do we have to show that? Like, because it already shows 81 on the calculator. When you put
So
it
it depends on if you've got other expressions kind of in there that you need to simplify. Do you need to show it? No, but understanding how this breaks down will work. It's important, especially if you have like variables with exponents, and being able to take the fifth root and then do the exponent as well.
Okay.
Does that make sense? So like we have here, I've got 7x to the 3/7. So that is the seventh root of 7x to the third power. Now, another way we can write this exponent doesn't have to be on the outside. It could also be on the inside. So an equivalent expression would be the seventh root of 7x to the third power. So be prepared to see it in either way, in either representation, because if it's applied to the internal portion, then we have to go ahead and apply that power rule where we do 7 to the third power as well as x to the third power. So we could have the seventh root of 7 to the third, which is 343, and then x to the third. Because 7 and 3 don't have a common factor, we can't simplify this anymore, and there is no seventh root of 343, so that's as simplified as we can get. Again, keep in mind the midterm is multiple choice, so when you have things with multiple representations, you need to be prepared to see it either way. And recognizing the equivalency of the two expressions, you may see an answer choice like this, or you may see an answer choice like this. You won't see both. So if you're expecting one and you don't see it, you got to recognize, hey, maybe that's in the other representation. Maybe it was simplified using a different method.
How'd you get 343 again?
7 to the third power, because 7x to the third.
Oh.
And so 7 to the third power is 343. Okay. All right, so we can apply our properties of exponents that I covered earlier. With the fractional exponents, we can simplify the exponential expressions first and then simplify by using the radical notation. So again, as a reminder, when we're multiplying with the same base, we can add the exponents together. So we have x to the 5/8 plus 3/8. When we add 5/8 and 3/8, we get 8/8, which just simplifies to 1. So we're just looking x to the first, or just simplified as x. When we have the division, we are going to subtract our exponents. So y to the 3/4 minus 1/4 gives us y to the 2/4, which reduces to y to the 1/2. Now, this says to write with positive exponents. And so since I can't simplify this any further, we're just going to leave it as y to the 1/2. But again, paying attention to the directions and equivalent forms of the expressions, if it said to write it using or simplify using radicals or the fractional exponents, we could rewrite this in an equivalent form as the square root of y. These are equivalent expressions, but we're going to focus on this because it says to simply write with positive exponents. Now, we have different bases here, so we can't add these exponents. All we can do is apply the power rule. So when I have an exponent raised to another power, we're going to multiply those exponents together. So I have r to the 1/5 times 2, and I have s to the 1/5 times 2. So we can multiply those exponents. We're going to have r to the 2/5 and s to the 2/5. Again, because these bases are not the same, we cannot simplify these using exponents any further than that. So now we're going to kind of combine and use the properties of exponents to simplify the radical expressions. So we have the 32nd root of x to the 4th, writing it in rational exponent notation. Again, the numerator is the exponent and the denominator is the index. So we have x to the 4 over 32. We can simplify that fraction as 1 over 8. And then we can either leave it in the rational exponent notation with the positive exponents, or we could have the equivalent representation in radical notation with the 8th root of x to the first power. Again, being able to recognize those equivalencies and being able to go back and forth depending on what answer options are available to you, what the question is asking for. So we've got our 15th root, y to the 12th, and z to the 20th. So we can write it with 12 as the numerator and 15 as the denominator. And then for z, 20 as the numerator and again 15 as the denominator. And then simplify both of those fractions independently. 12 and 15 have a common factor of 3. So we can reduce that as 4 fifths. And then 20 and 15 have a common factor of 5, so we can reduce it as 4 thirds. Okay, so we've got y to the 4 fifths and z to the 4 thirds. Here we want to write this as a single radical expression. In order to multiply radicals, the indices or the index of both radical expressions has to be the same number. Since they're not the same number, we can use rational exponents to our advantage to get them to be the same number. So I can rewrite this first one as x to the 1/4, and I can write the second one as x to the 2/3. The index is the denominator. Since we have two fractions, we can just get a common denominator. So the common denominator between the two is going to be 12. So if we multiply the first one by 3 and the second one by 4, that'll give us the common denominator of 12. So we have x to the 3/12, and then we have x to the 8/12. And so we've got that common denominator. So when we rewrite it in radical notation, we have the 12th root of x to the 3rd. That's the first one. And we have the 12th root of x to the 8th. This then allows us to write it as a single radical expression, the 12th root of x to the 3rd and x to the 8th. And then we can add the exponents together. 3 plus 8 gives us 11. So we have a simplified radical expression. We were able to add them together because the bases were the same. We could have done that in this step, but I wanted to show how we could go here to here and then here, because if the bases weren't the same, I could still get to this point. So if I had an x and a y, I could still write it as a single radical. I just wouldn't be able to then add the exponents together because I have different variables. So for example, if this was just real quick, here times the 3rd root of y squared, okay, different bases. All these steps would be the same. The only difference is I would then be left with x to the 3rd, y to the 8th, and I could not add those together, okay? Otherwise, all the steps would be the same, just this would be a y instead of an x. So here we want, again, the common denominator. So I have y to the 2/5 over y to the 1/7. And then I can get that common denominator of 35. So I'm going to multiply the top one by 7 and the bottom one by 5. So y to the 14/35 over y to the 5/35. Now that they have that common denominator, we can subtract the exponents, or we could write it in radical notation. Let's do this one slightly different than the first one. Let's go ahead and do the subtraction since we have the same exponent. So we can write it as 14/35 minus 5/35. Again, same base, we're dividing, so we subtract the exponents. That gives us y to the 9/35. And we want to write it as a single radical expression. So we're going to go ahead and write that as the 35th root of y to the 9th power. The 35th root of y to the 9th power. Right? Questions on that? Okay. So again, now we're going out of the rational exponents and focusing mostly on radicals. So we want to use the product rule of radicals to multiply. Assume all variables represent positive real numbers. This doesn't really change anything about our process. It's just if I have a square root or a fourth root, we want to assume that the variables are positive so that we can actually take the root. So it doesn't really change anything to our process. It's just saying, hey, let's simplify this, assuming that there's no issues. In order to multiply, we have to have, we have to have the same index. Since the index is the same, we can write this as the third root of 8 times 216. 8 times 216 gives us the third root, 1,728. We want to see if we can take the third root, which I have a sinking suspicion we can. The third root of 1,728 simplifies completely to just give us 12 as the third root. Again, same index, so we can multiply these together. We have the third root. We can multiply 27 and 64. 1,728. And then we can multiply m to the third times m to the third. Since we're multiplying, we add those exponents together. That gives us m to the sixth. We know the third root of 1,728 gives us 12. So we can go ahead and take that root. And then m to the sixth, the third root, 6 divided by 3 is 2. So we get m squared. The index here is 2. It's the square root, so we can go ahead and multiply these together. So this is the square root of x to the third times y to the fifth, numerator times numerator, and denominator times denominator. We have the square root of xy over 15. We don't have any perfect squares, so we can't simplify that any further. So that is as far as that goes. So our quotient rule means that we can we can take the root of the numerator and the denominator separately. So we can look at those independently. And we can say, okay, well, I've got the square root of 294 over r squared y, and I've got the square root of x to the fourth. And if we try to take the square root of 294, it gives us an irrational number. So we can't take the square root of 294. But we can look to see if we have any factors of 294 that are perfect squares. I'm trying a few different numbers here. Actually, let me just do a factor tree. That'll be easier. So 294 divided by 2. It would help if I actually did the division. There we go. Gives me 147. 147, that I can divide by 3. That gives me 49. 49 is a perfect square. So I've got the square root of 49 times 6. And then I have r squared and y. I can take the square root of 49. I can take the square root of r squared. I just can't do anything with the 6 and the y. So those are going to stay inside the radical. So I'm going to have 7r outside of the radical and 6y inside of the radical. And then for our denominator, the square root of x to the fourth is x squared. So we're left with our denominator of x squared. Yes?
Can't you just do 147 divided by 7 to make it go quicker? Because that's 147 divided by 7 is 21. And if you separate that, that's 3 and 7.
You can divide the 249 however you want, so whatever integers. I started with 2 just because I recognize it's even. And then I looked at 147. Yeah, you can divide it by 7 and then see the other 7. How you break apart that factor tree, it doesn't really matter. You're just looking for those perfect square factors or those matching pairs.
Okay.
So yeah, however you want to divide it out, that's fine. All right, so again, we're just simplifying like we did there. I can't take the square root of 98. So we want to see if we have any factors of 98 that are perfect squares. So if we divide 98 by 2, we get 2 and 49. 49 is a perfect square. So we can break 98 into 49 times 2. K to the 7th. K to the 7th, I can't divide 7 by 2. So I want to find the smallest exponent that is divisible by, the largest exponent less than 7 that is divisible by 2, which would be a 6. So I can split K to the 7th into K to the 6th times K. 8 is divisible by 2, so I don't need to change anything there. So the things I can take the square root of are 49, K to the 6th, and Q to the 8th. 2 and K will stay inside the radical. So I'll have 2 and K inside the radical, and then I'll take the roots of what I can. 7, K to the 3rd, and then Q to the 4th. And then 2K stays inside the radical. With fractions, I could try to simplify each of these and then simplify the fraction, but more often than not, it's a lot easier to write it as one single radical and then simplify the radical, the fraction first before you simplify the radical. So 320 divided by 5 gives me 64. And then x to the 5th divided by x just gives me x to the 4th. 5 minus 1 is x to the 4th. And then taking the square root from there gives us 8x squared. All right. Another page down. Questions, comments, concerns? Cool. All right. So now we're moving into polynomials. So we've got addition, subtraction, multiplication, and division. When we're adding, it's just combining like terms. The only thing we have to be careful of is when we're subtracting, we need to distribute that negative first before we combine any like terms. So with addition, there's no nothing to distribute. So we'll look for our matching exponents. We've got x to the 5th. So 2x to the 5th plus 6x to the 5th gives us 8x to the 5th. Then we've got x to the 3rd, 6x to the 3rd, and 4x to the 3rd. Add those together, 10x to the 3rd. Negative 9x minus 4x. Add those together, negative 13x. And we have simplified the polynomial as much as we can. We distribute the negative. We're going to be left with negative 3x to the 6th plus 2x to the 3rd minus 8. We're going to combine like terms, starting with x to the 6th, 5 minus 3, 2x to the 6th. Then we've got negative 5x plus 2x minus 3x to the 3rd. And then a positive 15 minus 8 gives me a plus 7, or a simplified polynomial. Multiplying, we will do our distributive property. So each of those is going to get multiplied together. Negative 2 times 9, negative 18. A times a is a squared. X to the 4th, x to the 7th gives me x to the 11th. Repeat the multiplication again on 11x to the 4th. So I'm going to have negative 22a x to the 8th. And then again on 5a, negative 10a squared x to the 4th. Distributive property with our binomials. So each term in the first multiplied by each term in the last. So we're going to get a 16x squared plus 48x minus 28x minus 84. Yeah, should be good. And then look to see if we can combine any like terms, which we can. 16x squared plus 20x minus 84. When we have a binomial squared, remember that is 3x plus 11 times 3x plus 11. Do that later. Otherwise, that's my point the whole time. All right, so we've got the squared. So the power rule doesn't apply because we have this addition sign. So we have to remember that we're multiplying it by itself twice. So we have to apply the distributive property. It's always going to give us a perfect square trinomial. So you can distribute and combine like terms, or just remember that our perfect square trinomial is always the first term squared, the last term squared, and then the product of the two terms doubled, with the last sign being plus and the first sign matching whatever we have. So whether we use distributive property or the formula with our perfect square trinomial, we end up getting the same result of 9x squared. If we multiply the two, we get 33x, double it to give us 66x. And then the last term squared is 121. When we have the same terms, but a plus and a minus, that's another special product that ends up giving us the difference of squares, because the 7x times -4 and the 4 times 7x, those two terms are going to cancel out when we add them. So we don't really need to concern ourselves with that multiplication. I'll show it, but I just want to highlight how we're going to have the first term squared. We're going to have the last term squared. If I multiply and I get the negative 28x and the positive 28x, those terms cancel out. So I'm just left with the difference of squares as the product of those two binomials. Hold, please, BRB. All right. So again, we've got the same terms, 1 plus, 1 minus. So this is, again, another factored difference of squares. So we can just square the first term and square the last term, 144y squared. Oh, that's fine. Okay. Simplifying. Before I move on to simplifying, questions with the multiplying, adding, subtracting polynomials. Okay. Simplifying rational expressions, we're going to want to factor first and then see what common factors we have in the numerator and denominator. So always look for a GCF first. We've got a GCF of 6, leaving us with x minus 3. And in the denominator, we have a GCF of 5, x minus 3. Since both the numerator and the denominator have that common factor of x minus 3, we can eliminate that common factor, so it simplifies to 6/5. Numerator, we want to factor the trinomial, so we have a product of 16 and a sum of 8. That's going to be 4 trinomial, so it's x plus 4, x plus 4. And then the denominator, a product of 20 and a sum of 9. That's going to be 5 and 4. So x plus 5, and x plus 4. We have a common factor of 4, x plus 4, so we can eliminate those, leaving us with x plus 4 over x plus 5. Okay, multiplying and dividing is simplifying just with a couple extra steps. Multiplication, we can just treat this as one big fraction because it's numerator times numerator, denominator times denominator. So we want to factor each of the polynomials within the numerator and denominator and then look for common factors across the whole expression having been multiplied together. So product of 36 and a sum of 13, that's going to be 9 and 4. And then our first denominator, 72 and 17, that's going to be 8 and 9. So x plus 8 and x plus 9. Second numerator, product of 32 and a sum of 12. So we're looking at 8 and 4. And then denominator is going to be 4 and 4 again. So we look for what we have in common. So my first numerator, I've got an x plus 9 and I've got 1 in the denominator. I've got an x plus 4 in the numerator and another one in the denominator. I've got an x plus 8 in the numerator and an x plus 8 in the denominator, and then I've got another 4 and 4. So since everything cancels out, it equals a nice big whopping 1. With division, it's the same process, but we just have to remember to flip the second fraction first. I prefer to do before I factor it. You can do it after you factor it, but before you simplify, you have to flip the fraction first. So our first one is going to stay the same. Actually, I'm just going to write it next to it. So this becomes 49r squared minus 70rt plus 16t squared. And the denominator becomes, what is that, minus 49 r squared minus 49rt plus 10t squared. And so we've got our fraction flipped. These are going to take a little longer to factor, so let's dive in. First one, no greatest common factor. So we've got 35 times negative 15. So a product of negative 525, and we want a sum of negative 4. So I really should have my graphing calculator emulator on here. Make it way easier to find these numbers. Let's see, negative 4. That's going to be 21 and negative 25. So 35r squared. I'm going to run out of room really quickly. Let's move that. All right, so 35r squared, and then we're going to split negative 4rt into 21rt minus 25rt. So if we combine those like terms back together, we get negative 4 plus 15t squared. Now we can factor by grouping. GCF of the first two is 7r, leaving us with 5r plus 3t. And then minus 5t, leaving us with 5r. Oh, that's a minus. Plus. There you go. Plus 3t. So our first numerator simplifies to be 7r minus 5t and 5r plus 3t. That's our first numerator. Is that it for now? All right. We will pause here. I'll finish factoring this around 12:45. I'll be able to pick back up, and then we'll keep going. And then all of this will be recorded and posted to my YouTube as well, so you can just look through the videos to find what it is you need. Like and subscribe. Comment for engagement. Boost my numbers. I really don't care. I have zero monetization.
You have to activate the comments. Put it on Instagram.
Are they not activated?
No, I tried putting W's in the chat.
It was working earlier. That's weird. All right, I'll check that out. All right, see you guys.
Bye, thank you.
And should be live now.
It is.
Checking the volume.
It is.
I was checking the volume. I was checking the sound.
Ask a question, see if you hear it on the line.
Hello guys, can you guys hear me? Yeah.
How many
You
views?
feel better now?
We have
I have 3 right now.
3 people watching.
So that's not on the bed. Empty.
All right, you are more than welcome to follow along. You are more than welcome to ask questions, but there will not be side conversations. Okay? Well, I'm going through. Here we go. Let's have fun. Because I find that fun. So, here we go. All right, so where I last left off, we were simplifying rational expressions, and with division, you just have to remember to flip the second fraction first. We are now factoring the polynomials so that we can simplify and cancel out any common factors. I factored the first one. So we started with the first numerator by multiplying 35 and 15, getting negative 525, and then looking for a sum of negative 4. That was the numbers 21 and negative 25. So I split the middle term. We did some factor by grouping. That was the first numerator. We're going to now just repeat the process again with the first denominator. So we're going to start with 25 times negative 18. And so we're looking for a product of negative 450 with a sum of negative 15. So let's see, negative 450, and I want negative 15. That's going to be negative 30 and positive 15. That'll give me the right product and sum. So we can split. Again, no side conversations, gentlemen. Thank you. 25r squared minus 30 RT plus 15 RT minus 18t squared. So we can factor by grouping 5r for the first one, leaving us with 5r minus 6t. And for the second one, we are looking at plus 3t to leave us with 5r minus 6t. So our first denominator is 5r plus 3t and 5r minus 6t. Yep.
Is the semester 1 exam review no submission assignment?
As I said earlier when you were in the bathroom, I'm not collecting it. I'm not grading it. You do what you need to do to prepare for your midterm. All right, so we're going to continue that again. We're looking at 49 times 16. So we want a product of 784 and a sum of negative 70. So 784 and 70, that's going to be 14 and 56. So we can split 49 r squared minus 14 RT minus 56 RT plus 16T squared. GCF in the first is going to be 7R, leaving us with 7R minus 2T. And in the second, it's going to be negative 8T, leaving us with 7R minus 2T. So 7R minus 8T and 7R minus 2T. And last factoring, we want a product of 490 and a sum of negative 49. And that'll be negative 14 and negative 35. So we can again split that. 49 r squared minus 14 RT minus 35 RT, right? Yeah, plus 10T squared. Wrong spot. There, factor by grouping, 7R minus 2T, and negative 5T, let's not forget the T, (7R minus 2T). So we're left with 7R minus 5T and 7R minus 2T. So that was a lot of factoring with those polynomials. So we have a numerator, a denominator, and a denominator. So we factored all four of those polynomials. So our completely factored expression is 7R minus 5T, 5R plus 3T. That's from here and here. The rest of that numerator, 7R minus 8T and 7R minus 2T. That's our entire numerator. Denominator is the rest of those factors, 5R plus 3T, 5R minus 6T, 7R minus 5T, 7R minus 2T. And so we're looking for common factors. We got 5R plus 3T in both numerator and denominator. We've got 7R minus 5T in both numerator and denominator. And then we've got 7R minus 2T in both numerator and denominator. So we are just left with the 7R minus 8T over the 5R minus 6T. All right. So a lot of factoring and then just looking for the common factors that will simplify. When we're adding and subtracting rational expressions, it's the same as adding and subtracting fractions. We have to have a common denominator first in order to add or subtract. So we take a look and see that our first fraction already has a common denominator, so we can just proceed by adding the numerators. So plus negative 2x is just minus 2x over the common denominator of x plus 1. I don't add the denominators, we just keep the denominator the same. We want to check to see, can we factor? And if so, can we then simplify? We have a GCF in the numerator of 2x, leaving us with x minus 1. and we have a denominator of x minus 1, which allows us to cancel those common factors, simplifying the expression to simply 2x. Our next one does not have a common denominator. We have 13x and we have 9x. Our least common denominator is going to be the product of 13 times 9 and x. They already have the x in common. So when we take a look at 13 times 9, our LCD is 117x. In order to get the first fraction to have that denominator, we need to multiply the top and bottom by 9. For a second fraction, we need to multiply it by 13. That'll give both of these the common denominator of 117x. So we will have 27 over 117x plus 13 over 117x. And we add those numerators together, gives us 42 over 117x. We want to look to see, can we simplify? Do we have any common factors? Looks like 117 should be divisible by 3, and it is. So is our numerator. 42 divided by 3. So we get 14 over 39x. Double check to see if we have any other common factors. 14 is 7 and 2, neither of which go into 39. So that is as simplified as we can get. In order to find our common denominator, we first need to factor our denominators. We have a difference of squares. And this one's going to factor to be x plus 4 and x plus 1. Both of these have an x plus 4 in common. What they don't have is the x minus 4 and the x plus 1. They don't share those. So our least common denominator will be the x plus 4, as well as the x minus 4 and the x plus 1 that are unique to the two rational expressions. So the first fraction will be multiplied by x plus 1 to get the common denominator, and the second one will be times x minus 4 to get the common denominator. So we're left with x squared plus x and minus 8. So minus 8 minus 32. So we're just distributing here to get our numerator. So we are subtracting those in the numerator, and we have our common denominator of x plus 4, x minus 4, and x plus 1. Distribute the negative, x squared plus x minus 8x plus 32 over the common denominator. Combine like terms, x squared minus 7x plus 32. We want to check to see if we can factor our numerator. So with a product of 32 and a sum of negative 7, let's consider some factors. 1 and 32, 2 and 16, 3 won't work, 4 and 8. Does not look like we can factor this. So we just need to leave that over the common denominator. And that is our sum. Questions on the rational expressions, adding or subtracting? Okay. Let's deal with evaluating some polynomials. If I'm given a function p of x and asked to find p of negative 4, then that's just saying, okay, well, when x is negative 4, what does my function equal? So to evaluate p of negative 4, we will just substitute in negative 4 for x and evaluate. We'll get 24 plus 7, which equals 31. So P of negative 4 equals 31. We can do the same thing with a fraction. So we'll have 2 times 1/2 squared minus 9 times 1/2 minus 8. So order of operations, we're going to square first, and we can multiply. 2 times 1/4 is 1/2 minus 9/2 minus 8. We've already got the common denominator, so 1 minus 9 gives us negative 8 over 2, which reduces to negative 4 minus 8 to give us negative 12. All right, another page down. When we're doing composition, we evaluate the inner function first and then take that result to evaluate the outer function. So first what we're going to do is find g of 4. So into g of x, we're going to plug in 4. 4 plus 3 is 7. So g of 4 equals 7. That means we can then replace g of 4 with a 7 and now evaluate f of 7 to get our final result. 7 squared plus 6 times 7. So we've got 49 plus 42, which gives us 91. Yeah, 91. So the result of the composition is 91. Here we're going to evaluate f of 3 first. So we will plug in 3 to our function f. So 3 squared plus 5 times 3. 9 plus 15 gives me 24. So we can replace f of 3 with 24 and evaluate g of 24. 24 plus 3 gives me 27. So the composition equals 27. An x value for g of x, we're just asked to find the composition. So g of x will be the input into the function f. So I will take 2x and I will substitute it in for x into the function f of x. So we'll have 7 and then 2x squared plus 5 times 2x. And we simplify. 2x squared is 4x squared plus 5 and 2x. And then we multiply 28x squared plus 10x. That is the composition of f of g of x. Questions on composition? Solving for a specific variable, we just want to isolate that variable by using our properties of equality, addition, subtraction, multiplication, division, just like we would solving a linear equation. And so I want to get t by itself. First thing I want to do is move the term that does not have the variable to the other side. So we're going to subtract p from both sides of the equation. A and P are not like terms, so I can't actually perform the operation. All I can do is denote the subtraction. Then to separate the T from the PR or the PR from the T, since they're being multiplied, we can divide both sides by PR. PR, there we go. That will eliminate those. So T will be isolated equals A minus P over PR. We want to solve for C. We're going to, again, get rid of any terms that do not have the variable that I'm looking for. So we'll subtract 32 from both sides. That gives me F minus 32 equals 9/5 C. And then we can multiply by the reciprocal of our fraction to cancel it out, which is 5/9. 9/5 times 5/9 eliminates. So we got a couple different ways we can write it. We can either distribute the 5/9 or leave it in those parentheses. Most common for this type of formula, since this is the formula for converting Fahrenheit to Celsius and Celsius to Fahrenheit respectively, we typically just leave it in the parentheses, but you could distribute here and multiply and simplify your fractions if you don't see the answer option that you're looking for, and instead it's just the answers without a parentheses. So just keep in mind that alternative notation. We want to solve for h. So we're going to go ahead and subtract the term that doesn't have the h in it. So 2 pi r squared. So we'll have s minus 2 pi r squared equals 2 pi r h. And then we can go ahead and divide both sides by 2 pi r, 2 pi r. So h will equal, and so both terms are going to be divided by 2 pi r. And we're going to split them because one of our terms does have some common factors that allows us to simplify rather than writing it as one single fraction. So h will be equal to s over 2 pi r. And then on the right-hand side, the 2's will cancel, the pi's will cancel, and one of the r's will cancel with that. So we're just left with minus r for our height. So we have these two different equivalent expressions based off the simplification.
Sorry, I didn't understand the 77. Why did you multiply for 5 over 9?
To cancel out the 9 over 5.
Oh,
You multiply by the reciprocal. 9 times 5 is 45. 5 times 9 is 45. So we're left with 45 over 45, which is to cancel fraction, multiply by the reciprocal. Mhm. All right, so we've got bacteria in a petri dish that triple every day. The formula for the growth is shown here, where T is the number of days after 2 bacteria were placed in a dish. How many bacteria are in the dish after 8 days that they are placed in the dish? So we're just evaluating n of 8. So T represents the number of days. So we'll evaluate 3 to the 8th power, which is 6,561, and multiply that by 2. And after 8 days, there are 13,122 bacteria in the petri dish. We have a formula for compound interest. We just need to know what each part of the formula is referencing. P stands for principal. That's the amount of money you start with. So Daryl is borrowing $3,750. So that is our principal. At a rate of 10%, that refers to the rate, but we need to make sure we convert it to a decimal. Okay, which would be 0.1. Just divide your percent by 100. Compounded semi-annually, that refers to the compounding frequency, which is n. So the compounding frequency, it's how many times in a year it will compound. Semi-annually means it will happen twice a year. Quarterly is 4 times a year. Monthly is 12 times a year. Weekly would be 52 times a year. So those frequencies annually would just be 1 time a year. We want to figure out how much he owes at the end of 4 years, which is our variable T, and we will round to 2 decimal places. So we'll have 3750 times 1 plus our rate. Put that back here. Hold, please. I plug in my dying. There we go. Okay. Our rate of 0.1 divided by our compounding frequency of 2 raised to the power of 2 times 4. And we can go through and evaluate this step by step. So 1 plus the 0.1 divided by 2 gives me 1.05. And then 2 times 4 gives me 8. I'll do the 1.05 to the 8th power. That's going to give me a big long decimal. And we're going to end up rounding, but do not round until the end. We want to round to 2 decimal places, so it's a good idea to keep 2 or 3 decimals more than what your final answer would be. I don't need to write out the whole thing. It's 455,444. We don't need to keep the whole thing. We can just kind of leave it there. That should be enough to preserve our rounding. And then we can multiply it by the principal amount and round it to 2 decimal places. We're left with $5,540. And then 457, that's going to tell the 5 to round up to a 6. There's our 2 decimal place rounding. Being able to write exponential growth or decay in order to calculate a missing value within the formula. So again, our general exponential growth or decay is going to be that we're going to have an initial value, A, and then we're going to have a base, which refers to our growth rate, and then we're going to have a time. So the base can be either 1 plus or 1 minus whatever our growth rate is. If it's growth, we are adding that rate. And if it's decay, we will subtract that rate. So here we're looking at a growth of 8%. So our base will be 1 plus 0.08. We have A is our initial amount, and we're given the time in years. So we can use our equation of 507 times 1.08. Again, that's that 1 plus 0.08 raised to the power of 7 to calculate the final amount X years after the growth started. And so 1.08 raised to the 7th power is approximately 1.713, and the number kind of keeps going. We can multiply that by the 507, the initial amount. That's going to give us 868.908, and the number keeps going. Rounded to the nearest whole would be 869 is the final amount. Yep.
Can you explain it again, please?
Yep, I'll do it right now. So again, our exponential growth or decay is A, B, to the x power t, or t, because t is usually time. A is our initial amount. Our base is going to be either 1 plus or minus the rate, plus if it's growth, minus if it's decay, and this is our rate. We want to write it as a decimal. So we're going to take our initial amount of 304. We are going to multiply it by 1, since this is decay minus 0.05. And then our exponent is 7, because it's 7 years. X is the number of years. So when we subtract, we get 304 times 0.95. We're going to do the exponent first, 0.95 raised to the 7th power. That's going to give me 0.698, and the number keeps going. If we multiply that by the 304, we get approximately 212.2 2, 9, so on. That 2 tells the number to round to stay at 212. There will be no rounding. So growth, we're going to add the rate, and decay, we're going to subtract the rate, multiply that base, do the exponent for the number of years, and then multiply that amount by the original amount that we started with, and that gives us the final amount. So here we're given, again, a growth. We have a percent growth. That's our exponential. We have a rat population grows at a rate of 9% every month. If there are 200 rats in June, how many rats should be expected by next June? So that will be 12 months later. So we've got a initial amount of 200. That's our A value. Our rate is 0.09 and its growth. So our base will be 1 plus 0.09 and our time frame is the 12 months because it grows 9% monthly. So 200 to start times 1.09 raised to the 12th power and multiplied by the initial amount, and we get approximately 562.5 rats, which is 563 rats are expected in June.
Why is it 12 and not 1?
Because it's compounding monthly.
But it wasn't supposed to be yours. So 12 months.
It's growing at 9% every month. So the time interval is tracked every month. Number of students attending summer school is decreasing by 8% each year. And so we have an initial value of 701. Our rate is 0.08. Since it's decreasing, our base is 1 minus 0.08. So we can take our initial amount of 701, multiply it by 0.92. Again, this is growth each year, and we want the number of students attending in 5 years. So 5 is our exponent, 0.92 to the 5th power, and then multiply that by the 701 starting amount. We get approximately 462.0. So we expect there to be 462 students still enrolled in summer school in 5 years. All right.
Why did you subtract add?
Because it's declining. It says it's decreasing every year by 8%. All right, solving our radicals. We are going to isolate our radical term and then raise it to an exponent equivalent to the index. That allows us to eliminate the radical sign and then leaving us with an equation that we can solve. That new equation solution set contains the solutions to the original problem, but we will need to go back and double check these solutions because we will often end up with extraneous or extra solutions. So we'll square both sides of our equation to eliminate the radical, leaving us with x minus 5 equals 64. We can now add 5 to both sides of our equation, x equals 69. And then we want to double check our answer by plugging it back into the original equation to make sure that it gives us a true statement. The square root of 64 is 8, so we know that that was good. No extraneous solutions. We want to add 6 to both sides first before we use our property of exponents here. It would help if I actually wrote 6. We can go ahead and square both sides to eliminate the radical. 7x minus 6 equals 36. Now we can continue to solve for x. we add 6, 7x equals 42. And then we divide both sides by 7, which means that x equals 6. Plug it back in just to double check. 7 times 6 is 42. 42 minus 6 equals 36. The square root of which is 6 minus 6 equals 0. So we know our solution works. Here we subtract 9. We have the square root of 3x plus 7 equals 9, or negative 9. We can square both sides. 3x plus 7 equals 81. We subtract 7 from both sides. 3x equals, what am I looking at? 74. Yeah, 74. No, 70, yeah, 74. Okay. And then we divide both sides by 3. Now, we take this value and we plug it back into our equation. We have the square root of 3 times 74 over 3 plus 7. That gives us 74 plus 7, which is the square root of 81. Plus 9, plus 9, plus 9. Square root of 81 is 9 plus 9. That does not equal 0. So we know that this answer was extraneous. It does not work. And since there's no other options available, we know we have no solution. Now there's a shortcut here, and it's right at the beginning. If we notice, when we move and isolate the radical symbol, we have a square root set equal to a negative number. There is no real number that I can take the square root of that'll give me a negative value. So right here, we know there's no valid number here that will work. If I have 81, I get positive 9. I'll never get negative 9. So we know right here that this is not going to work. We don't need to go through the whole process, but it goes to show why it's a good idea to check your solutions before you put in an answer. Solving our rational equations, just like with simplifying rational expressions, we have to have a common denominator to add or subtract. Now what we're going to do here, instead of actually adding and subtracting with the common denominator, because we have an equation, we can multiply by the common denominator to cancel out the denominators, allowing solving to be left with either a linear or a quadratic equation. And noticing that our least common denominator is going to be x plus 3, x minus 3, because both of these fractions have that denominator. So we're going to multiply the entire fraction, or the entire equation, by x plus 3 and x minus 3. All the terms, x plus 3, x minus 3. In our first fraction, the denominator will cancel with x plus 3, leaving us with 2x minus 6. In the second fraction, x minus 3 will cancel, leaving us with 8x plus 20. And in the last fraction, both will cancel, leaving us with just the 6. So now we can go ahead and simplify and solve the resulting linear equation. Make sure you distribute that negative. Negative 6x minus 30 equals 6. Negative 6x, we subtract 30 gives, add 30 gives us 36. X equals negative 6. Just like with radical equations, rational equations can give us extraneous solutions because this new equation contains the solutions to the first one, but it's not necessarily the same solution set. So we want to plug this back in. And what we're looking for is making sure that it doesn't cause my function to be undefined. Why my eraser's not working. Try that again. There we go. So if I plug in -6 and -6 and -6, it doesn't give me 0, which is what we're concerned about. And so because that gives us non-zero numbers, then we know that our solution is valid. So we're just checking for anything that would cause our function to be undefined. In this specific instance, the only values that would do that are either -3 or +3. Those are the only numbers that would give us the denominator of 0. So as long as I'm not getting one of those, then we know that we're good. So we'll factor to look for our least common denominator. We see that these two are the same, so we only have to factor 2 of these polynomials, not all 3. Product of -15, sum of 2, we're looking at 5 and -3. And this will be also x plus 5 and x minus 3. And here we're looking at x minus 3 and x minus 3. So they all have an x minus 3 in common, but this one has 2. So we need to include that as part of our least common denominator, and then we need to add in the x plus 5. So our least common denominator is x plus 5, x minus 3, x minus 3. We're going to multiply everything by all 3 of those factors. X plus 5. Now, 2 of them are going to cancel out for each set. In the first one, x plus 5 and x minus 3, leaving me with x minus 3, x plus 7, and my denominator cancels. Minus, the minus 3 ones will cancel, leaving us with 7x plus 35 if we distribute. And then on the end, the plus 5 and one of the minus 3s cancel, leaving us with x minus 7 times x plus 3. So we will distribute x squared plus 7x minus 3x minus 21 minus 7x minus 35, x squared plus 3x minus 7x minus 21. Combine like terms and set equal to 0. So on the left, we have x squared. These will cancel, minus 3x, and these will add to -56. On the right side, x squared minus 4x minus 21. And then we will subtract. All right, I'll keep going on this for a little while, and then again, the video will be posted to my channel. So if you need to finish up reviewing, anything I don't finish up today, I will continue tomorrow until I finish the whole thing. Other than that, I will see you all mañana.
Yo, I saw the video.
All right, so let's keep working through this. All right, so the x squareds will cancel, And we'll go ahead and add 4x to both sides. So we get x minus 56 equals negative 21. And then we're just going to add 56. So negative 21 plus 56 gives us 35 as our value for x. As long as we didn't end up with a value of negative 5, positive 3, which is what would cause any of these denominators to be 0, then we know that our solution is probably valid. All right, let's go ahead and do a couple absolute value equations, and then we will take a break there and leave the factoring and solving polynomials for tomorrow. So we're going to solve the absolute value equation. Just like with radicals, we want to get the absolute value term isolated by itself. So we have the absolute value of x equals 3. And then we need to consider that absolute value measures distance from 0. It makes the numbers positive. And so there are two values for x that will give me an absolute value of 3. X can be 3 and x can be negative 3. Here, our absolute value expression is already isolated. And so again, anything that will give me 8, an absolute value of 8 is either 8 or negative 8. So as long as 7x plus 4 equals 8 or negative 8, then it's a valid solution for x. So we're going to split it into two equations to figure out what could possibly cause our 7x plus 4 to equal 8 or negative 8. We'll solve for both of these. So we'll subtract 4 from everything. So we'll have 7x equals 4, and we'll also have 7x equals negative 12. Divide both sides, or all sides, by 7. And we're going to be left with x equals 4/7 and x equals negative 12/7. Both of those will cause the absolute value expression to equal 8 or negative 8. And there's our two solutions for x. One more. We're going to go ahead and isolate first. So we'll have 6x plus 5 in absolute values equals 4. And we'll split 6x plus 5 equals 4, and 6x plus 5 equals negative 4. We'll subtract 5 from everything, giving us 6x equals negative 1 and 6x equals negative 9. Divide by 6, x equals 1/6, or x equals, this fraction will simplify to negative 3/2. We'll pick up on this part tomorrow. This used to be part of the unit chapter 6 in previous years. This is actually just our unit 1 in quarter 2. This is our first unit in quarter 2, but it is just factoring polynomials for the most part and solving polynomials. And we'll pick up from here tomorrow. I hope you found this helpful, and if you've got any specific questions or if you think I messed up somewhere, please politely throw me a comment, and I will try and respond to you or make an adjustment to the video.